According to the curvature of the Earth, how far do you have to travel from one point to end up 1 mile below the tangent from the first point, assuming no change in elevation? So here I have this circle representing the Earth, and I have an XY axis in there with the center of it being the center of the Earth, the origin, and this green vertical line is our tangent line to the Earth. Now we're going to start our walk on the right side where I have that red dot. So the red dot is the start. And we're going to walk counterclockwise until we end up right here. That is 1 mile below the tangent line. So it's 1 mile distance from here to the tangent line. So we'll say that this is 1 mile. Now, whatever the radius is, we'll just call it r from now, from the origin to this original red dot is r. But now that we are 1 mile to the left of that on the x-axis, we are now at a distance of r minus 1 from the origin. So if I draw this right here, this is r minus 1. Let's write that better. So we got r minus 1. And if I just draw a little dotted line down from there, this is also our x. So this gives us our first part of this is x is r minus 1. Now remember your two important equations for your coordinate of any point on a circle. For the unit circle, x is cosine of theta and y is sine of theta, but for any general circle with a radius of r, x is r cos theta and y is r sine theta. So we have x is equal to r minus 1. We also know that x is equal to r cosine theta, so we get that r cosine theta equals r minus 1 right here. So from there, we want to try to get theta. Of course, my goal of what I'm trying to do is find out what is this angle right here. So if I could find out what this angle is, that's going to let me know what the arc length is, which is what we're trying to solve for. We're trying to solve for the arc length right here. So how far did we go along the circle from the starting point to this new point? So to solve for theta in this r cos theta equals r minus 1, we divide by r on both sides, leaving us with cosine theta equals to r minus 1 over r. And then we take the inverse cosine, or arc cosine. We get theta equals the inverse cosine of r minus 1 over r. So now we have our solved for theta. Now, remember the arc length formula here now, because once you know the angle and you know the radius, you know the arc length. The arc length S is equal to theta times r, and this is in radians here. So S is equal to theta, which is cosine to negative 1, r cosine, r over r minus 1 times r. And this now is our final formula for finding the arc length. Now, I looked it up on Google, and in my first search, I found that the Earth's radius is 3958.8. Now, this is a little bit different if you look on different sources because the Earth is not a perfect sphere. On some places, I see it as low as like 39 for the vertical or the polar radius, and sometimes I see the equator radius in the 3960s. But I'm using 3958.8, which I found on Google. Now, putting that 3958.8 into this equation for arc length, so 3958.8 times the inverse cosine of 3958.8 over 3958.8 minus 1 gives me S equals 88.98. So we get an arc length of 88.98. So that is how far we traveled along the Earth. So if you travel 88.98, and I'll put the units there, miles, along the Earth, you end up 1 mile below the tangent line from where you started.